Let's build a real browser game with zero libraries, just the raw HTML5 Canvas API and plain JavaScript. A square you drive with the arrow keys. A red circle to dodge. A game loop running 60 times a second. And it stays in bounds, no matter how hard you push. No engine to download. No framework. No build step. Your whole game is one HTML file and one script. Send someone a link and they're playing. This is the loop every engine hides from you. Learn it once, and Unity, Godot, and Phaser stop feeling like magic. Every line is on screen, and you can copy it as we go. One quick, honest note before we open the editor. If you enjoy building from scratch like this, the natural next step is more finished games to take apart. So I put together a Phaser game dev bundle. It's $19, 10 complete browser games, with the full source for each one. Reskin one and ship it. It is completely optional, and the link sits in the description. That's the whole pitch. Now let's write some Canvas. Every Canvas game starts with two things, an element to draw on, and a context to draw with. In the HTML, we add a single canvas element. We give it an ID of game, and a fixed width and height, 800 by 600. Then a script tag pulls in our game code. The width and height here are the real pixel size of your drawing surface. Set them on the element itself, not just in CSS, or your game looks blurry and stretched. Now the JavaScript. We grab that element with document.getElementById. Then we call getContext, passing the string 2D. That hands back the CTX object, every shape, every color, every frame goes through it. That one object is your whole paintbrush. A game is just a picture redrawn many times a second. To do that, we need a loop, and the right one is requestAnimationFrame. You hand requestAnimationFrame a function, and the browser calls it right before the next repaint, usually 60 times a second. Inside, we do our work, then ask for the next frame again. That keeps it going forever. Here's the part beginners skip, and it matters. The browser passes your loop a timestamp. We subtract the last timestamp from it, divide by 1,000, and we get delta time, the seconds that passed since the last frame. Why bother? Because frame rates differ. A slow laptop might hit 30 frames a second, a gaming monitor 200. If you move by a fixed amount each frame, the game runs at different speeds on different machines. Multiply your movement by delta time instead, and everyone moves the same distance per second. That is frame rate independence, and it is the single most important idea in this whole video. Now let's actually draw something. First, the player, just a plain object holding an X, a Y, a width, and a height. Then the draw function, and it runs every single frame. Rule 1 of Canvas, clear before you draw. We call clear rect across the whole canvas, from 0 to the full width and height. That wipes last frame's picture clean. Skip that clear, and the player smears a trail across the screen as it moves. Clearing gives you a fresh slate every frame. Then we paint. Set fill style to a color, here a bright blue. Call fill rect with the player's X, Y, width, and height. A solid rectangle appears exactly where the player is. Clear, then draw, that's the rhythm of every frame. A game you can't control isn't a game. So let's read the keyboard. The trick is a tiny object called keys. It just remembers which keys are currently held down. We start it empty. Then two listeners on the document. On key down, we set keys, for that key, to true. On key up, we set it back to false. The events key property tells us exactly which one, arrow left, arrow right, and so on. Notice we are not moving the player in these listeners. We only record the state, pressed or not. The actual movement happens later, in update, where we simply check the keys object. That split keeps input smooth and reliable, even when several keys are down at once. Now we connect the keys to the player, inside update, and update takes delta time as its argument. We pick a speed, 300 pixels per second. If the left arrow is held, we subtract speed times delta time from the player's x. Right arrow adds it. Up subtracts from y, down adds to y. Because we multiply by delta time, that's 300 pixels every second, on any machine. But there's a problem. Push the player far enough and it slides right off the edge of the canvas, gone forever. We need to keep it in bounds. The fix is clamping. We wrap the x in math.max of 0, and math.min of the canvas width minus the player's width. That pins x between the left wall and the right wall. Same idea for y, top and bottom. Now the player moves freely, but it can never escape the screen. A square in a box is a start. Let's add something to avoid, a circle enemy, and detect when they touch. Rectangles come from fill rect. Circles are a little different. We call begin path, then arc. We pass the enemy's x and y, its radius, a start angle of 0, and an end angle of 2 times pi. That last part is a full circle. Set a fill style, red here, then call fill. There's your enemy. Now collision. Our player is a rectangle, the enemy roughly a box around its circle. The simplest reliable test is axis-aligned bounding box. Check if the two rectangles overlap on both the x-axis and the y-axis. We compare 4 edges, the player's left against the enemy's right, the player's right against the enemy's left, and the same top and bottom pair. If all 4 overlap, they're touching. That single boolean is the seed of every hit, pickup, and score in your game. Step back and look at what you just built, with no engine at all. A canvas element and a 2D context, your drawing surface and your brush. A requestAnimationFrame loop with delta time, so movement is fair on every machine. A draw function that clears, then paints. A keys object fed by key down and key up. Movement that scales with delta time and clamps to the bounds. And a circle enemy with a bounding box collision check. That is a real game loop, clear, update, draw, repeat. It is exactly what Unity, Godot, and Phaser do for you behind the scenes. You just wrote it by hand, in plain JavaScript, in one file. That's your game from scratch, no engine, just the Canvas API. You now understand the loop underneath every framework on Earth. Here's your next move. If you want 10 complete games to pull apart and reskin, the Phaser Game Dev Bundle is $19, full source, link below. And I'm turning this same game into something bigger next, a score, health, and enemies that actually chase you. Subscribe so you catch it the day it drops. Now go make it yours, add a second enemy, keep score, speed things up. Then send a friend the link. See you in the next one.